Hello and welcome to today's class. Today we have this math challenge before us here. If you're new here, this is Online Maths TV. Subscribe if you've not subscribed to our channel. Here we release videos all the time. Now, how do we solve for the value of x? We are having x to the power of 5 minus 1 equal to 0. So the first two here, we take our solution here. So let's take our solution. All right, so the question again is our x to the power of 5 minus 1 is equal to 0. Now we send this one to this side of the equation. So this is going to give us x to the power of 5 equal to our positive 1. Now if we decide to raise this side of this equation to the power of 1 all over 5 and we raise this to the power of 1 all over 5, we're going to have our x will be equal to 1. But if you check the power here, is 5. So it suggests that we look for 5 good roots to this challenge. So how do we get the other 4 roots? So with that, we're going to make use of the Euler equation, and it says that your e, okay, e to the power of your pi iota, the plus our 1 is equal to 0. This is a nice equation that helps us to solve some of this top polynomial equation. Now, we have to move this one to this side of the equation. If we do that, this is going to give us our e to the power of pi iota is equals to minus 1. But here we are having our plus 1 here. So how do we change this to this minus 1 to plus 1? We have to raise this to a set of constant, which is 2k. So this is going to give us here our e all raised to the power of pi I, the bracket, our 2k is equal to our minus 1 all raised to the power of 2k. Now, what is k? K is a set of constants. Okay, so our k, let's get the value of k. K is equal to 0, 1, 2, 3, and 4. Okay, because we're having our x raised to power of 5. If we rewrite this will be minus 1 all raised to power 2 all raised to k, right? And minus 1 to the power of 2 will give us positive 1. And because of the values of k we have here, and so positive 1 to the value of k will give us 1. So our original equation here becomes, or we cannot say this now implies that our e all raised to the power of 2k pi iota is equal to 1. If you check this carefully, we are now having our positive 1 here. So we can go back to our original equation and substitute the whole of this expression we have here in place of this 1 here. So rewriting this equation, this is going to give us our x to the power of 5 is equal to our e all raised to the power of 2k pi iota. Good. Now we have this expression. This will enable us to solve for all the 5 roots. So we raise both sides of this equation to the power of 1 all over 5. Okay? So this is going to give us our x to the power of 5 all raised to the power of 1 all over 5 is equal to, we do same thing to this other side. 2k pi iota, right? All raised to the power of 1 all over 5. With this we go with this. Okay, we are now left with our x here. So we have x will now be equal to, if we use this to open this, we're going to have our e raised to the power of 2k pi iota all over our 5. Now this is the standard expression where we're going to get all 5 roots of x, or 5 values of x from. So we're going to take the first one, our x1, when k is equal to 0. So when k is equal to 0, what is the value of x? So we're going to have our x1 will now be equal to our e raised to 0. Because if we put k to be 0, everything here will turn to 0. So we're going to have our e raised to the power of 0. And e to the power of 0 will give us 1. And so we have our x1 is equal to 1. this is the first value of our x that will satisfy this equation. Now, when we take our k to be 1, which is x2, so for our x2, we're going to have our k to be 1. And if we have our k to be 1, our original equation, our standard equation, will now becomes our e all raised to the power of 2 pi iota all over 5. Okay, then our x3 will give us similar thing, but this time we are taking our k to be 2. So if we take our k to be 2, so we're going to have here e raised to the power of 4 pi iota all over 5. And the next one, we're taking our k to be 3, so which is our x4. So our x4 becomes our e raised to 8 pi iota all over 5. And lastly, which is our x5, will now be equal to our e raised to 10. Oh, sorry, is it 10? This will give us 6, please. So we have here 6. Then this will give us 8 pi iota all over our 5. So these are the 5 other roots. These are the five roots that will satisfy the original equation. So this brings us to the end of this math class. So if you learned something from this video, give the video a thumbs up. Thank you for watching Online Maths TV. See you in our next video. Bye.